In this example, basically we take the training data out of the table, we create our feature vector using a standard Spark map operator, and then we take that feature vector and feed it into an MLlib algorithm, logistic regression in this case. So this is pretty exciting. You can piece together a lot of different systems, or what would have been different systems in a single tool in Spark. You can do all these things in one place. And in case anyone out there is familiar with Shark, just keep in mind Spark SQL is not the same thing as Shark. Shark was a separate project, or is a separate project, pardon me, also from the UC Berkeley AMP Lab. It was the first version, let's say, of providing SQL on top of Spark. Shark still exists. It's got its own Hive query planning optimization. Eventually, it will start to use the Spark SQL query planning and optimization. But for now, these are totally separate projects. There will be a point in the near future where Shark essentially just provides the serving layer, the Hive server 2, if you will, or the Shark server 2, and then connects into Spark SQL. But for now, these are separate systems, and Shark basically provides a lot of the same capabilities of Spark SQL, but in a separate application. Okay, moving on, and I have to move a little quicker here because we've got just a few minutes left. Let me continue to talk about some of these other systems that are included in Spark. So one of them is Spark Streaming. It's very exciting. Basically building on top of the same core platform, but providing streaming, an API to access streams of data. So one of the coolest examples or one of the most easy to understand examples I like to use is, for example, let's say we want to do an application of Twitter trending topics, right? So we're essentially looking for the most popular hashtags, and we want to do that over the course of, we want to count as our